Hi guys, today we're going to learn more about parametric equations vectors in calculus. Mainly here I'm going to show you how to use a calculator. Okay, so let's start reading this problem. A particle moving along a curve in the xy plane has position x of t, y of t. At time t, with dx dt equals to sine of t power 3, dy dt equals cosine of t power 2. At time t equals 2, the object is at the position 7, 4. Okay, so please note that they are saying something about position, but you have here, technically speaking, the velocity vector. Okay, do you see it? Okay, so let's read the first part. Write the equation of the tangent line to the curve at the point where t equals 2. So you know that when you are looking for a tangent line, you need two things, a point and the slope. Do you agree with that? Now, you do have the point at t equals 2. They are giving it to you from the hypothesis of the problem. So you're going to use the beautiful point 74. Now, the business here is how in the world we're going to find the slope of this curve. Pretty easy. You know the first formula that we covered when we were covering parametric equations, it was dy dx. Specifically in this situation, we're going to evaluate this at t equals 2. So you do know, okay, that this is going to be what? This is going to be dy dt divided by dx dt, okay, evaluated at 2. Now ask yourself, do you have dy dt? Yes, we do. It's cosine of t squared. So what are you going to plug as a t? Well, 2. So what do you have? You have cosine of 4 because 2 squared is 4. And then in the denominator, you are going to have dx dt, which is given to you because you have sine of t power 3. Okay, so you have that 2 power 3. What's going to be that is 8. So you have that it's sine of 8. Okay, so you can leave it like that, or I'm going to plug this in the calculator. Okay, so you are going to plug this in the calculator. What do we have? We have that it was cosine. Okay, so you have cosine of 4. Okay, and then you have that this is going to be divided by sine of 8. Okay, and then you have here your decimal, so you know that this is going to be negative 0.6606. Since they want 3 decimal places, I would put it like that. You can round it as negative 0.661. That's fine as well. Okay, so the equation, okay, of the tangent line, okay, at what was it, t equals 2, is going to be equal to y minus 4. Y minus 4, this is your y, is equal to negative 0.66, you can round it as 1 here, x minus 7, and that's pretty much what you have for a. Isn't that simple? Could you plug this in the, yes you could, but I mean, what are you going to do, plug the 2 here and here? I mean, you can do that, right? Because you have the calculator, but it's not needed. Okay, so the second part, B, find the speed of the particle at t equals 2. Okay, so what is the speed? The speed, okay, evaluated at t equals 2 is going to be the square root of what do you have here? It was x prime of t square plus y prime of t square, right? Okay, so we already knew that this is a formula, but that's not enough. Okay, they are giving you specifically a value, okay, t equals 2. So what are you going to do here? Well, they are already giving it to you. Here is going to be what? Sine of, what's that? 8. Okay, all of it square plus, and then you have that it's going to be cosine, okay, of what's that? 4 square, and everything inside the square root. Okay, so you can leave it like that, but they are asking for the calculator because they want you to give the decimal number. So let's plug it here. No, I don't want the answer there, I want the square root. Okay, and it's going to be sine of 8. Okay, and all of this square plus, and then I want my cosine of 4 and all of this square, so watch out with those squares. Okay, they are always tricky. And then you have 1.1857. okay, so you can leave it like that or round it, it's up to you. Okay, Now for part C, let's see what they are asking for part C. Maybe the calculator is more required. For what values of t, when t is between 0 and 1, does the tangent line to the curve have a slope of 4? Find the acceleration vector at this time. Okay, so first, before finding the acceleration vector, you want to find this value of t, right? Okay, so you want to know the slope is going to be equal to dy dx. This is nothing new for you, okay? So you know that dy dx is going to be equal to cosine of t squared divided by sine of t power 3. And the question is, you want to know when this is true, right? So what are we going to do here? Well, solving this is not something that we can do from pre-calc and that's it, right? It's going to be horrendous. Therefore, you need a calculator, okay? So we're going to use the solver, okay? And you are finding t, right? We want to find t, okay? So what we're going to do here is very simple. Let me show you what I'm punching here so you can see it, okay? Menu, I'm going to algebra, you go to solve. Please note that this is very important that you have a CAS calculator with you, okay? So after that, what I'm going to do here is I'm going to have my fraction, okay? In the numerator, I have my cosine of, and for is here, I'm going to just use x instead of t, okay? You can use, if you prefer, you can use t if you want. It's up to you, okay? That one is going to be sine of x power 3, okay? And then you want to know when is equal to 4. This is the equation that we're trying to solve. But you need to tell the calculator that you want to solve it for x. And in addition to that, not only that, you have a restriction on the x. So what I'm going to do here is very important. Let me show you. You press Ctrl equal and you are going to select this bar. Please make sure that that bar is outside of the parentheses. Do you see it? And then you can put the restriction, okay? The inequality symbols are in the same spot. Ctrl and then the equal, and then the variable in this case is x, so I'm going to call it x there, okay? And your restriction, your upper bound is 1, okay? So you click enter and then you have the situation, okay? So I have a lot of students that they tell me why we have this symbol, because it's rounding maybe to the 20th or 25th decimal place, but you don't care about that, okay? So you just you just copy your t, okay? You are going to copy as 0.61, 64, whatever, okay? So please note that this is not our end result. Here we finish this part, but we also need to find the acceleration vector. So for the acceleration vector, you know that I'm going to do the acceleration evaluated at that value, okay? But you are going to use all the decimal places of the situation. You know that the acceleration is the derivative of velocity. Therefore, what we're going to do is we're going to take the derivative of velocity at that point. So first thing that I'm going to show you, I'm going to show you how to store this with all the decimal places, okay? So do you see that what I did? Okay, I just copy the value that I have here, okay, and then I'm going to place myself there, okay, and I do Control Store. You need to see this arrow, sorry about that, and then you are going to call it, let's call it A, okay, so we call it A. So every single time that I type the letter A, okay, I'm going to have this number, okay. So now what I'm going to do here, because I do know that this is velocity, okay, I'm going to take the derivative of this one. If you take menu, okay, go to calculus and then the derivative at a point, you have the x there. The value is going to be a because we told the calculator to store a as that number, and that's why it's bolded here. And then you're going to type your expression, okay? So you have that it was sine of t to the power of 3, okay? So hit enter and that's going to be your decimal, okay? So this is the x component of the acceleration vector, okay? So I copy that number here, 1.109, and that one you can just round or just copy the first 3 decimal places because that's a final answer. Now I'm going to do a similar situation with this one, okay? What you can do when you have situations like this is you can go up, copy the expression here, as you can see it's highlighted blue, hit enter, and then what you're going to do here, let me show you how to be lazy. You put that as a 2. Obviously, we need to change this one because we know that it's a cosine, so you can just type it here with the keyboard if you want. For me, it's faster. I don't know, maybe for you, no, but for me it is. So you have that your y component of the acceleration vector is negative 0.457, okay, and that's going to be your acceleration vector. Now ask yourself, did we solve everything that they are asking for? Yes, we found the t, okay, for when the slope is 4, and then we found the acceleration vector at this time, okay, so we finished our part C. Isn't that simple? So because it's with the calculator, it doesn't mean that it's going to be horrible. The numbers are going to be a little bit ugly, but that's pretty much it, okay. So let's move on to part D, okay. So here you have to find the position, okay, of the particle at t equals 1, okay, and you're like, what? We have solved this before. Yes, indeed, but this one, the integral is going to be a little bit more interesting, okay. So again, we're going to use the fundamental theorem of calculus, your new best friend, okay. So what you know is, you know that the x component, we're going to start with the x, okay. You know that the integral of the x prime of t dt is going to be equal to, if you have limits of integration by fundamental theorem of calculus, what limits of integration do we have? I know that I have 1, and my other limit of integration in this case is going to be 2, because that's the information that they give you, and you can see that this is the values that you have, okay. So it's going to be from 1 to 2. This is the one that I'm finding, and this is the one given to me. That's why I have those two. So you have that by FTC, you have that this is x of 2 minus x of 1, okay. So you do have from the hypothesis of the problem, okay, I'm going to integrate the situation. What was the integral? You are like all happy, and you're like, oh, fine, this is super easy to integrate. No, it's not, okay. So you're all happy with the 7 minus x of 1, right? And you want to solve it for this one. But this integral is absolutely horrendous. Why? Try use substitution. Do you have 3 t squared outside the sign? Nope. So what are you going to use? The calculator, okay? So let's use the calculator here. Okay, so you have the integral, okay, calculus, okay, you go to calculus there, go to the integral, okay, put limits of integration, okay, and then you're going to put sine, okay, and then x to the power of 3, okay, and x here, okay. So that's going to give you a value, okay. So you copy that value, 0.2181, and then you know that this is going to be equal to 7 minus x of 1. The x of 1, I pass it to the other side, okay. So I have that this is going to be 7 minus 0.2181, okay. So what I'm going to do here is 7 minus this value. Okay, so I have that x of 1 is going to be equal to, and you have that it's, let me write it here, 6.7819. Okay, you can round it, of course. Okay, so do you see it? Now you're going to ask me why you didn't do the typical without the FTC, and then you solve for C. Let me show you. If you enter this into your calculator, please let me make sure that you are seeing it. It doesn't have limits of integration. If I put that will give me the same thing. It's not a typo, and it's not your calculator. You are not giving limits of integration to this. Therefore, the calculator is going to be pretty much very confused. Okay, so please make sure to use this type of equations and this type of fundamental theorem of calculus, this part of the fundamental theorem of calculus. Otherwise, you are not going to have a solution, and it's not you. It's that simply you are not using the specific part that the calculator can solve. Okay, on the other side, on the y component, you know that it's going to be sort of the same business. You have that it's going to be the integral from 1 to 2 y prime of t dt is going to be equal to y of 2 minus y of 1 by fundamental theorem of calculus. Similarly, you have an ugly situation here because your y prime, what's your y prime, is cosine of t squared. Okay, so again, ask yourself, if my u substitution is u equals t squared, do you really have 2t outside the cos? No. Okay, so again, this and this value, it was going to be 4. Okay, so I have negative y of 1. So what are you going to do again? you go to your calculator. Let me repeat the steps so you can see it. Menu, calculus, okay, then you have integral, okay, so you have that it's going to be from 1, and then you can write your expression. In this situation it was cosine x squared, and then here it was a 2, and then my dx over here. Okay, so I have my value over there. I copy my value here, negative 0.443, okay, and this is going to be equal to 4 minus y of 1. Then I pass my y of 1 on this side, okay, I have the 4, and you can see that this is going to be plus 0.443, okay. So what you're going to do here is I do the 4 and I do a minus, so I can minus that one, okay, because minus minus is 4. Okay, so y of 1 is going to be equal to 4.44306. You don't need as many decimal places as I have. And then you have that the position, okay, of the particle, okay, at, what was it, at t equals 1, right, is going to be, and I leave it as a point, 6.7819, comma 4.43, okay, and that's pretty much it for this problem. Isn't that nice? So if you have questions about how to use a calculator or something, write it in the comments. I can answer any questions that you have. And that's it for today. I hope that you find this video helpful. Bye.